Good evening, friends. I share a slide. It is visible to you, right? Now, yesterday we are talking about the single screw extruder, and there are some parts. uh, Single screw extruder. We have seen the combination of screw and barrel. That is a screw pump. Pump is it has to pass the plasticized polymer into the screen pass, beaker plate, and the die with a uniform geometry. Hopper is a funnel-like device mounted on a hopper throat, forced on a constant reservoir of a material. Yes, there may be a hopper loader, there may be dehumidifier as per the material, and it will always provide a constant volume or constant type of a feed to the feed zone of the barrel and screw. Barrel is cylindrical housing in which the screw rotate. I told you the barrel is not very strong like injection molding barrel. The injection molding machine barrel have a higher pressure. It is a higher pressure barrel because there may be more than or maybe at least 35,000 psi pounds per square inch pressure developed inside, and therefore the barrel should be resistance for such a pressure, high pressure. It should be withstand with such a high pressure. But here in this case, the barrel of the extruder, it is not very strong as like a injection molding barrel. Hopper throat, yes, I told you the water circulation below the hopper throat and around the hopper throat, it is required we stop the melting of the polymer. The drive, AC DC drive, I told you yesterday only. Speed reduction gearbox. We have a motor which having a speed more than 1000 RPM. Therefore, we have to use something, a drive system to reduce such a speed. Generally, we use speed maybe up to 120, 130 RPM for single screw extruder. Therefore, transmission system from the rear side of the extruder is very important. We have to reduce the speed of the screw from 1000 to 100 RPM. And that is possible only by using the gearbox and transmission system. Therefore, friend, the single screw extruder consists of a screw rotating in a heated barrel or cylinder to which the material is fed. Therefore, you know the function of here feed hopper. We supply the feed, extruder screw and barrel, which plasticize the material, drive systems. It contain motor, gearbox, transmission. Here may be rubber, maybe belt, V-belt is there, joined to the various type of pulleys, gearbox, different ratio. So we can reduce the speed of a screw motor, and motor is there to do the torque to the screw so that screw rotate. Yes, very important. Thrust bearing assembly. This thrust bearing assembly, which contains a taper bearing there, which will take the axial load, and there are also the general bearing or a radial bearing, which take the radial load. Therefore, there are two type of torque developed when the screw rotate at the backside of the extruder. And hence, the thrust bearing are very important, dear friend. It is also defined as the bitten life. For the thrust bearing is very important. The life of the extruder is depends upon the thrust bearing life. How much?
So what is the function of this?
It is a function. Its function is it will help. It will take the axial load when the screw rotate and the radial load, because you are passing the material inside the barrel and it's a viscous material. Therefore, a lot of torque is developed inside by the rotation of the screw with a such a viscous material, and that load it get developed at the rear side of the extruder, and therefore at the rear side of the extruder where the shank is there, hub is there, a lot of pressure is developed there, and it should be accommodated, friend. Otherwise, there's a possibility bending of the screw. Hence, this thrust bearing which help for the rotation of the screw. I told you there are two type of load observed. One is axial load. Axial load means by weight, the screw is maybe 22, 22:1 L by D ratio of that. And therefore, it is having a longer. It should be withstand there at the time of rotation. And there is a very few millimeter tolerance is there between the barrel and the stride of the screw. It should not, the screw should not touch to the inside barrel. And such a axial load and radial load is taken care by this thrust bearing assembly or thrust bearing, there is a taper bearing and the radial type of bearings. Friend, radial type of bearing take the radial load, or it is also called as a normal bearing or a general bearing. That is take the radial load when the screw rotate, and axial load is taken by the thrust bearing, which is a taper one. Therefore, I told you just now, the life of the extruder depends upon this. How much hours you are going to run the machine? What at what load? That is also very important. The time, how much time, and what is the load on the machine, and what parameter. And very important thing at speed, at what speed. Therefore, speed, load, and time. These are the parameter of the life of the extruder. Speed, load, at what load, and speed, load. These are the two things, and time, at how many hours you are running the machine. These three things will tell you the life of the extruder. If you run the machine at very high speed, the life will definitely decrease. Thrust bearing life. If the thrust bearing life decrease, then again you have to change that thrust bearing life. Therefore, a optimum speed at what that load. If you increase the load at a minimum speed, then also the life will be that bearing will be not work. By wear and tear, it will definitely destroy. And hence, we have to take care of that. Thrust bearing assembly, taper bearings, and a general bearing, which are helping us to accommodate whatever the pressure developed, whatever the load developed by the screw rotation inside the barrel, that can be accommodated at the rear side of the extruder. And that is taken care by the thrust bearing assembly. And therefore, friend, thrust bearing assembly is a very important while designing the extruder. Now, heating and cooling systems. I told you there are both are present there. Barrel heated by band heaters, and the cooling may be done by spraying water on the barrel, all the zones, or there may be blower. There may be blower. When the temperature get increase, immediately that will sense the controller. The controller will again give the signal to the blower. The blower immediately start. Therefore, friend, it is a very automation nowadays in the systems. And this automation will give you higher production, good quality, with minimum time. Therefore, cooling of the extruder done by spraying water or by using the blower on each zone. From the bottom side, there are small blower which will start immediately. Even that blower also join at the different sensors. Feed zone different, compression zone different, material zone different, die zone different. This blower, suppose the die temperature is high, immediately it will start. It will bring the temperature down, whatever we have said there, temperature. Even if the feed zone temperature is higher, immediately suppose something happened and it's showing feed zone temperature is very high. That time it sends by sensor, thermocouple, and the message will send to the controller. After controlling that, immediately the blower will start at the feed zone, and it will try to create temperature down. That is meant whatever the temperature we have set initially for the feed zone. This is a unique automation which is present on this present extruder, and this is a new modification. Now, friend, therefore, remember this thing: heating and cooling are necessary for the extrusion system. Now, screen packs and a breaker plate. Yesterday, I told you what is the screen packs. These are nothing but a simple, network stainless steel wire structure is there. जाली और sieve बोलते हैं हम लोग उसको. And there may be a setup, maybe 60, 90 or 120 mesh. The sieve is always described on the basis of mesh, right? What is a mesh? Can anybody explain me what is a mesh? Hello? Can anybody define what is a mesh? Hello? Am I audible to you, friend? Hello? Am I audible? Hello?
Hello?
Am I audible to you?
Yes, sir, you are audible. Yes, sir, audible.
Yeah. I'm asking what is the mesh size? Mesh. Do you know about mesh? MESH, mesh? We are here, screen packs and a breaker plate. There are different type of
Sir, mesh.
setups. Mesh is, it is always used for the screen, right? तो जाली होता है, विंडो को हम लोग लगाते हैं, to protect from machar, right? That type of stainless steel sieve is there, or छाननी, हम छाननी भी बोलते हैं उसको. And that is a place in front of screw tip, and that have a different type of mesh, 60, 90, and 120. So what is the mean by mesh? Do you know? Mesh is nothing but the number of holes per square inch. 1 inch area में how much holes are present in a 1 inch area? That is called as a mesh. And hence there are 3 type of mesh frame: 30, 60, and 90 size. We are placing together in the breaker plate. And I told you the function of breaker plate and screen pack assembly yesterday only, that it filter the material. That means it will stop the foreign particle. Second, it will stop the unplasticized granules. Third, it creates the continuous back pressure at the rear side of the extruder. And the fifth one, and the fourth one, the turbulent flow, which is created by the screw and barrel, it gets converted into laminar flow. This is the function of these two things. Then die is there. Friend, that depends upon the hollow die is there. Right? If you want to rod, then hollow die. If you want to pipe, there are a mandrel type of die is there, straight through die, cross set die, or maybe offset die. Suppose there are different type of dies available in the market as per the production you want. Lastly, the temperature and pressure control. I told you temperature can be controlled by the blower present on the extruder. Pressure also controlled by the thrust bearing assembly, and the extruder is running smoothly here. Now, there are some definition. Compression ratio. It is the same like our injection molding screw. Channel depth in the feed zone divided by channel depth in the metering zone. Very simple. Channel depth at the feed zone divided by the channel depth at the metering zone, usually from 1.5 to 1.5 to 4.S to 1. This is the compression ratio. Therefore, suppose 1 millimeter at the metering zone, there are 4 millimeter maybe in the feed zone, like that. Therefore, it varies 1.5 to 4 in the of the feed zone divided by S to 1 of the metering zone. L by D ratio. Length of the screw is nominal length divided by the diameter of the screw. Length may be feed zone, compression zone, metering zone, all nominal length, or maybe flatted length. There may be another definition, overall length, that contains shank plus hub plus flatted length. Therefore, that is called as the overall length divided by the diameter of the screw, nominal diameter, and hence is a 20 S to 1, 20 to 22 S to 1. L by D ratio of the extruder. The important specification: nominal dia of the screw, output kg per hours, feed zone, the function of feed zone to transport the material from hopper to compression zone. It compacts the material and eliminates the air gap. Compression zone, transport the material from compression to the metering zone. Therefore, is soften the material here. Metering zone, it melts the material, mix the material, pressurize the material, and pump the material. Material means melt. So, friend, this metering zone, they have a lot of effect on the production. Again, here, in many machine, feed zone and metering zone having a higher ratio or a higher length. Generally, it is a 50, 25, 25. It is like that. Feed zone having a length 50%. There is also thermocouples provided here, which will help the actual temperature of the die. Now, screw nomenclature, same. What is the pitch distance between the center of two adjacent flight? See now, this is a pitch. It's called as a pitch. This is called as a width, channel width. Pitch, channel width. This is channel. Distance between the flight and the root diameter of the screw. Shown by the C letter. If you see here, the land is here. The flight length. These are the flights or thread. This is a helix angle thread. They also play a very important role. Maybe 17.7 or 17.8 helix angle. Then, see here, there are two diameters. The root diameter and the outer diameter. Outer diameter is shown by capital D and root diameter is there, RD. Root diameter, the root diameter. This is the outer diameter. The channel depth is the flight depth plus the distance between screw and the inside of the barrel. It is called as channel depth. So, friend, they are the basic nomenclature of the screw. Any question here, friend? Hello? Any question here? The nomenclature of the screw. Screw have a lot of different names. Therefore, you should know the various names of the screws, part, section. This is a helix angle. See the perpendicular drawn here to this flight. So this angle is called as a helix angle. These are the flights. These are the flight depth, channel depth or flight depth. See, channel depth is different. Flight depth plus clearance between outer diameter of screw and inside diameter of the barrel. So friend, these nomenclature are very important, which will change completely the geometry of the material. Now, screw types are there, different type of screw types. General purpose screw, PVC screw, nylon screw, two-stage screw, vented screw, segmented screws is also available for the special purpose. Now, this is a general purpose screw of the extruder. Why it is general purpose screw frame? Because it process 3 to 4 material. For example, SDP, polypropylene, polystyrene, like that. Hence, it is called as a general purpose screw. We can process 3 to 4 material by using general purpose screw. Now, friend, see here, feed zone lower, see the compression zone constantly increase here, see the metering zone, constant diameter. Here is also constant root diameter. Here, root diameter goes on increasing here. See, very long. Why this? The material should get plasticized. And that's why, compression, the material get compacted and the granule convert into the liquid polymer. And then it will push to the metering zone. See this design frame. It's called as a general purpose screw. I told you, it is used for 3 to 4 material. Now, PVC screw. See here in the PVC screw, how to differentiate PVC screw with the general purpose screw? Hello? Friend, this is a PVC screw. This is a PVC screw. See here 100% compression zone, no feed zone, no metering zone, 100% compression zone. The root diameter goes on increasing from this place to this place. 100% compression zone. The root diameter goes on increasing from this zone to up to the metering zone. And here, there's no wall. See, wall is here, but wall is not there. Why this? See, there is no metering zone, no feed zone, only the compression zone. See, from this place to this place. And therefore, you cannot use this screw for PVC. Or you cannot.
Residence time is very low for PVC, sir.
Correct. 100% correct. Your answer is 100% correct. Because PVC is sensible, very sensitive, heat sensitive polymer. It start to degrade immediately. If you take the virgin PVC, virgin powder PVC, it degrade at 0, white powder. It don't have flow at all. It start burning there at 80-degree temperature. But we are doing the compounding of PVC. We are adding plasticizers, stabilizer, extenders, oils, many things we are adding, additives. And that's why we can process PVC material maximum up to 200, not more than that. Not more than that. Maximum 200. If we exceed 200, then PVC will start to burn. Again, the color will change. And therefore, maximum. But it is people are, by fear, people are running the machine at 180, 190 only, not more than that. Here, residential time should be lowest. वैसा ही material आता है, वैसा ही material get should out. If the material falling here, it should be immediately out, friend. This is a screw, such a screw used for the thermoset material also, thermoset. PF, MF, VF, all thermoset material. Such a screw required there, friend. Even length is also less. See, L by D ratio is also less. And such a heat sensitive material, all thermoset material, PET material, polycarbonate, PVC, it should be have a minimum residential time. And minimum residential time means it should have 100% compression zone. Now, see the nylon screw now. Here, see the metering zone 45%. Feed zone, compression zone only 5%. See the feed zone 50%. Why this? Anybody can tell me why nylon having a compression zone only 5% or maybe 10% maximum, not more than that. But see the feed zone, it is very high.
It's a semi-crystalline material, sir.
Yes. This is a nylon screw.
No, semi-crystalline material. Huh?
Yes, not semi-crystalline. It is a highly crystalline material. Highly crystalline material. I told you, if you see the other material, polypropylene, polyethylene, they don't have a very sharp melting point. They melt at a specific temperature, slowly melt. But here nylon, I told you that day only, 250, 255, nylon 66, nylon 6, 215. Sharp melting point. If you increase the temperature to 54, nothing will happen. There is no melting of the polymer, nylon polymer. But if you increase to 1 degree, that is a 55, then it will dissolve like a water. It will melt like a water flow immediately. And therefore, nylon is difficult to process, friend, because we have to address everything there. We cannot use this nylon screw for polypropylene, polyethylene, PVC. Remember this thing. See now here, a very long. This indicates that it is a heat stable material. Its melting point is very high. And after that, it immediately melt. See now here, very long. Therefore, residential time is also very long here. But see here, within a one flight, the material get transferred from feed zone to the metering zone. That means once it melt, immediately usko melting zone में फेंक दो. Just throw it in the melting zone. After melting.
मतलब शेयर करने का जरूरी नहीं मेटे ग्रैन्यूल्स को.
नहीं, कुछ जरूरत नहीं है. It immediately melt. वाटर प्रूफ होता है नायलॉन का. It is highly crystalline material. बाकी देखो, बाकी पॉलीमर में क्या होता है, विंडो होता है. यहाँ से
Okay.
स्टार्ट होता है मेल्टिंग को, वहां खत्म होता है। तो विंडो यानी 10 डिग्री का, 5 डिग्री का, 6 डिग्री का, इसमें ऐसा नहीं है।
यानी कि स्क्रू स्पीड का शेयर का जो स्क्रू स्पीड जो है स्टैंडर्ड स्क्रू में कोई फायदा नहीं है, स्क्रू स्पीड चेंज करके नायलॉन में कुछ नहीं कर पाने
नहीं नहीं
करने
नहीं,
वाले।
नथिंग नथिंग नथिंग, यू
हाँ,
कैनॉट,
अगर
यू कैनॉट।
नायलॉन स्टैंडर्ड स्क्रू में यूज करेंगे तो स्क्रू स्पीड और इसका रिलेशन नहीं आएगा।
हाँ, यस यस, करेक्ट। देयरफॉर इसको क्या होता है, इट इट रिक्वायर अ हायर फीड जोन। पूरा उसको, इट इज ही स्टेबल मटेरियल, धीरे 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 मेट होता है वो। बट सी नाउ, आई टोल्ड यू, विच इन 1 डिग्री मिरेकल होता है। 254 होगा तो भी मेट नहीं होगा। बट जहां इधर इधर आता है तो उसका बराबर मेल्टिंग पॉइंट आता है 255 इमीडिएटली। इधर इट डिसॉल्व लाइक अ वाटर, एंड इमीडिएटली हमको यहाँ पे उसको निकाल देना चाहिए, इमीडिएट यहाँ से इधर तक, मेल्टिंग जोन तक उसको फेंकना चाहिए, लाइक लाइक अ पंप। एंड देयरफॉर फ्रेंड, it is a very simple process. Nylon. Now there are some material.
And another point, if there it should be it is no, very less residence time should be there in melting temperature, in melting condition.
Correct,
If
correct.
once it is melted and it is reached the peak,
Yes,
the volume should be very less.
correct,
Otherwise,
correct.
it gets degraded soon.
It is, yes, correct. You are 100% correct. But here,
Oh.
see the feed zone, it have a constant diameter, root diameter, right? Therefore, it will take a time. It take a time to, it first take the heat. It is just, melting there, but not 100% melting, but it just absorb the heat in a feed zone. And when the temperature reach at 255, it start to melt immediately. Dissolve, it will melt like a water, friend. बाकी बाकी पॉलीमर में,
Meaning, zone 1, zone 2 temperature should be near to the throat temperature. Zone 3, it should be 50% of melting, near to melting.
correct,
Zone 4
correct,
will be complete melting temperature,
correct, 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 100% correct.
above the melting temperature.
Yes, above. It may be 270, 275, like that.
Understood, sir. Okay.
Yes. Correct. Now, if you see now, two-stage vented screw is available in the market. See, there are two screw. This is the first screw up to this, and this second screw up to this. There are, see now here, feed, metering zone, compression zone, and feed zone. See here also, the metering zone, compression zone, and feed zone. This is called as a two-stage screw, or it is also called as a vented screw. Vented. Now see, some material, they produce a gas. They produce a gas, and the gas should be go out. Otherwise, it will create the problem in the melt, in the product. Hence, see now यहाँ तक material melt होता है. After melting, immediately यहाँ पे lower pressure, zero pressure. यहाँ पे pressure यहाँ पे pressure build up होता है. See now, after pressurizing here, the material completely melt here. But sudden, see the sudden here pressure 0. And immediately the material fall here. But the screw is rotating that time. The vent may be here. The vent may be here at the bottom, this side. Now, can anybody will tell us why the bottom side vent? And maybe it will the blow, the material will come out from the vent, but it is not like that. Because polymer is a melted condition. It will just rotate along these flights. It will never, that blow this. And therefore, whatever the gases created here, that gases can be removed from this place. Here or here, maybe top or maybe bottom. The vent is provided here to remove the gases. And after that, again the material get melted here, and the process is going on. The friend, vented screw or two-stage screw generally used for the material, stable material, but it creates lot of gases. And that's why we have to remove that gases. Otherwise, it will spoil our melt. Therefore, any question here, friend, about the PVC screw, general purpose screw, nylon screw, and two-stage screw? Any question here? Hello?
No, sir.
Okay, we'll go now.
Sir, what are those stable material where this vented screws used, sir?
Stable material, general purpose screw. General purpose screw. For polyethylene, for polystyrene, for SDP, polypropylene. Yes, general purpose screw.
No, vented screw.
Hello?
Where the vented screws are used.
Vented screw, the material which is a, that which give the gases after melting. After melting, जैसा polymer melt करते हैं हम लोग, वैसा it the gases will pass from that.
Maybe form material.
Oh, it may be compounded material.
Pica, like pica or something.
Yes, even polyethylene also, yes. Peak
Okay.
also, even some rubber type, there's some blends, some alloys, PCPBT blends, PCABS blend. Yeah, that time some gases produce, and the gases should be go out, and that's why here we are giving a vent here, maybe 1 or 2 mm vent is there, and it is the gases will go out. You will get the here free from the air or maybe gases.
Understood, sir. Okay.
Yeah. Now the mixing elements. I told you yesterday, the mixing element always at the metering section only. In the segmented form, right? We can add. If you see the screw, we can that do the section. There is a shaft, right? Inside the shaft, and they have a slot at that shaft, and we can add this. This is a pin type mixing element. Then this is a dull mesh type. It is a cavity type. Cavity transfer. Why are we using this type of, see, even barrel also having some, spaces here. See here, this is a barrel. See here, barrel having some spaces here. See the pin, pins are there, stainless steel pins. See here, number of pins are there. These all are added, and see here, there are number of slots. See here, up and down, up and down, up and down, up and down. See here. Why this happen? Why this type of mixing elements require? Because, see, material mixing is very important, friend. In extruder, suppose any material which is heat sensitive material, for example, paint or polycarbonate, such a material, now, because we are adding many things there, not, that in an extruder, we are adding first the material at the hopper. But again, we have to give some dosage, maybe at feed zone, maybe at compression zone, maybe at metering zone. See, some material, they are heat sensitive, like PVC. Or maybe you take polyethylene terephthalate, PET. Therefore, we have to add color at the last moment. Last moment means in a metering zone. Now, we have to add that color, because if the color, if the color, we are adding color here in the hopper, what will happen? That color, it slowly, it will going forward, color. And the red color become that some other color here, up to here. The we expect that the red color should be to the material, but it is not completely red because that the pigment is not stable to that heat restoration time. And hence we have to add pigment here in the metering zone. But if we add here pigment, what will happen? It is not properly mixing. Not properly mixing. And hence we have to use such a type of pins, such a type of slots, such a type of cavities. It will mix the material completely and give the minimum, that heating effect. Therefore, friend, this is a very important here. The mixing aids, which will mix the ingredients, some stabilizers, plasticizers, something we have to add. Many times we are adding, many things, friend. Many additives we are adding at the last moment because that additives are not heat stable throughout the barrel. Are you getting me, friend? Hello?
Sir, is the addition in extrusion or in injection molding, sir?
No, only extrusion, only extrusion. Don't mix injection. Injection में नहीं करते हम लोग.
Okay, sir. Okay.
Yeah. Now thrust bearing, I told you.
So, sir, the additives like additives and glass fibers, they will be also mixing in the metering zone only.
No. Glass fiber is at initially. Don't worry about that. Glass fiber, nothing will happen. Glass fiber we are adding at the at compound only, friend.
But
yes, ask.
at the metering zone only we will add the glass fiber.
No, metering zone color. Suppose you want to give some yellow color, shining wala color.
Okay.
That color you can add because इतना लंबा आते आते it will get faint. वो yellow का बन जाएगा pale yellow. That color which are expecting, we are not getting the same color because you have added that color in the hopper only. We don't want to add it.
Master batch addition will be at the metering zone. Huh?
Yes. Correct. You are
In our
100%.
plant, after the screw operation, then only we are using the this thing. We are mixing the glass fibers. The
Yes.
reason behind this, otherwise glass fiber will become powders inside
Correct.
itself.
Correct.
So fiber
correct.
property, to retain the fiber property and strength, we add only at the end of melt zone.
Melting zone. Correct. But that glass fiber, it having a different type of grade. Which grade you are using? Glass fiber?
Grade, I don't know, sir, but
Acha.
all glass
We are
fibers,
using
whatever
Nippon
we
glass
mix, it is
fiber,
only at the end.
juicy glass fiber.
Hello? Yes?
We are using Nippon glass fiber, juicy glass fiber.
Yes. Generally, what happens if the glass fibers having a longer length, right? They are added at the initially only. But if and suppose the length, the size and structure and geometry of the glass fiber play a very important role here. Some don't want to add the glass fiber initially at the hopper only because definitely it will try to damage your barrel and screw in the fit zone and compression zone. And in many material, I agree with you because it will get wear and tear at these two zone, compression zone and fit zone. There are many extrusion systems we can add, but the size of glass fiber are very important while adding in the melting zone. And here, that's why we are adding, that these mixing aids, which will help to mix these glass fiber colors and other things. Now, any question, friend? Hello.
Sir, can we see the previous slide, sir? Is there any difference between that splines and the bubbles, sir? Bubbles in the metering zone?
Here, see, metering zone, it will give the, some type of, that different type of flow it created, see here at this, so there's a gap here, see this gap here, this giving some the action there, it will just get rotated type of action there, like that. And due to that, that this thing get a completely wipe out. When, see here, it is coming here down, it's a going up. See, even barrel also, see the barrel also here. And this type of structure will help you a distributive flow, distributive. See, we are expecting in the, see now here, a distributive flow is there, right? And it is a dispersive flow, thus dispersive and distributive. Are you getting me, friend?
Last one I understood, sir. But what about the splines and the whole A and B?
We have to distribute the material. Distribute karna padta hai, right? It should be uniformly distributed in the melt, and that's why it will help by mixing. It will distribute uniformly. Whatever you are adding the additives, that get uniformly distributed into the melt by this type of a cavity type of things, right? Cavity transfer type. It creates a distributive flow.
Is it pertain to any particular material?
No. We want, that any type of ingredients. You take any type of ingredients, and if you want to mix it properly, right? So many times what happen, some material you are adding, some additives you are adding, they are gathered only at one place. They are not uniformly mixed there. That should be distributed at uniform, equal level. And due to this, see now here, you are, from this place to this, it is get uniformly distributed into the melt. The pigment, maybe glass fibers, maybe any type of adhesives, antioxidant, stabilizers, UV stabilizers, like that. Therefore, here's the dispersive flow, here's the distributive flow. Both are meaning are different. Dispersive and distributive. These things are very important, friend. Any question, friend? Hello.
Okay, sir. Thank you.
Okay. See, thrust bearing assembly, I told you, lot of pressure generated by rotation of the screw due to the die resistance, breaker plate and screen pack resistance. Lot of pressure here, front side. And that pressure should be accommodated here. These are a tapered bearing. It is called a thrust bearing. Here, these are tapered bearing. Therefore, here the screw fit into the thrust bearing located behind the feed hopper. Right. What is the function of this thrust bearing? To absorb the thrust force acting on the screw inside the extruder barrel. This thrust force is called a thrust bearing. The name is thrust bearing. Now, what is the role actually? This bearing prevents the screw from the moving backward. Right. The screw cannot come backward direction because of here is a complete lock is there. And I told you the bearing life depends upon the load, that is the pressure, screw speed, and time. Therefore, if you use the high speed, therefore, again the life will be less. For twin screw extruder, several smaller bearings join in a one shaft is used. See now, friend, here also the bearing, here and here. There are general bearing or radial bearing, which will take the radial load. This will take the axial load. this sleeve is there, which will help to rotate this screw, and it will help to also the bearing, tapered bearing. Therefore, whatever the thrust or maybe torque generated here, that can be accommodated here. Any question here? Any question, friend? Hello. Any question here, friend?
No, sir.
We will take a 2 minute, then we will
Okay.
start again. Yeah. Now, heating and cooling elements. There are three methods of heating extruder: electrical heatings, fluid heatings, and steam heatings. Generally, people are preferring electrical heating because it gives the uniform heating and easily controlled. There are some fluids, generally at specific laboratory level, they are using the fluid, but it is again the spoiling all the extruder systems. The steam heating is also provided with some extruder. Now, electrical heating, there are induction heaters, cast-in heaters, band heaters, and the mica insulated and a ceramic insulated. These are the types of the heaters used in the extruder. Now, friend, the cast-in heaters or maybe this induction heaters generally used for a specific type of extruder, and the band heaters having a conical shape, they are using on the large diameter barrel. Then mica having its own application and ceramics. The electrical heating is the most commonly used due to the accuracy, reliability, and easy to hook up. Now, induction heaters. AC current passes through coil, thus setting up a magnetic flux. Heat is generated from the resistance offered to the body ED current set up by the flux. The barrel is heated directly by its resistance to the induction current. See now here, induction coils are there. There are the heat insulator are there. This is a barrel. And here the space is there for barrel cooling purpose. Here. Okay. We can cool the barrel provide here by providing the cooling channels. See now here the ED current which will flow here and it will create the magnetic flux. And once it is set up, it will try to heat the barrels. Then here the laminated iron heating circuits also there. You can provide here like this. And due to that, the magnetic flux will develop. Here are thermocouples which will give the actual temperature of the barrel. This is a induction heating. What are the advantages of this? Accurate control of temperature, good provision for the cooling system of the barrel, no possibility for the hot or cool spots. It is a relatively high cost induction heaters. Then cast heaters. The insulated heating elements are cast into semicircular or flat aluminum blocks. These aluminum blocks here, which are machined to match the surface to be heated. Therefore, cast-in resistance heaters. See here, aluminum blocks. This is aluminum also block. As the thermocouples are there. Therefore, generally aluminum will, you know that it will easily pass the heat. The very good conductor of heat, aluminum. And that's why it is used here in the cast heaters. Band heaters. They consist of nickel chrome or other resistance wires, that is a mica or ceramics. So here we are trying to differentiate between mica and a ceramic insulator. Mica is very flexible, supplied as a single piece. Ceramic, rigid, supplied in a two halves. If you know that the barrel is in circular, therefore two halves are required. But it is in single piece, mica. That you know very well because you have seen that. Can withstand a load of 23 to 31 kilowatt per meter square. Can withstand at a higher heating load. Ceramic, because it is ceramic. Shorter service life, mica. Here is a better service life. They are less expensive, mica heaters. Well, it is it is always cheaper one. But these are more costly. And also, maintenance also, you have to maintain that. Should not fall. Because there are two halves are there. Fluid heating, mostly commonly used for the extruder is oil. It may be heated by the any suitable means, electrical heating. The heating system consists of heater, a circulating pump, surge tank, and a heat transfer channel in the extruder barrel. Steam heating. The high specific heat and latent heat of vaporization of water makes steam an excellent heat transfer medium. Latent heat is very important, friend. Specific heat and latent heat. However, this system is not frequently used because of the low maximum temperature that can be achieved. A need of working with a high pressure piping, frequent leak of a steam that require a shutting down of heating for repair and the corrosion effects. Therefore, people are initially using, but they have seen that there are many faults. Steam leak hota hai, maybe steam leak, repairing problems, corrosion problems, and therefore people are not generally using steam heating for the extruder. Now, cooling systems. I told you cooling is very essential for the extruder because heat is developed by the sharing heat. Barrel heating is needed to prevent overheating that may cause degradation of material. For small extruders, fans that blow air over around the barrel. See, these are blowers are here. I told you, these are the heaters, these are the blowers here, which will pass a cooling effect on the barrel and immediately it will control the temperature. The friend, cooling channels are there, which will help to cool the barrel. Fins on the barrel or heaters to speed up the heat transfer. A water fog spray over barrel. Many times water fog or spray water is there. Continuous controlled vaporization of liquid water. And copper tubing carrying cold water is sometimes used. Many times there is a coil around the barrel. That also copper because it is a heat transfer metal. Therefore, friend, fins are there. Then blowers are there. Water fog also. There are a number of technique to cool the screw, not screw, barrel. Hopper cooling, I told you in a very few lecture, first lecture, water cooling is used to cool the hopper throat to prevent the breaching and to protect the rubber part or plastic parts present in the screw support assembly. Screw cooling. The cooling may freeze a layer of a plastic on the screw root, reducing the channel depth, thus producing the more shear at the cost of throughput. I told you because if you cool the screw, there is a higher slippage between the granule and the screw, and that is we require. Also, this may also reserve the required relationship between the friction coefficient, low friction coefficient on the screw, high on the barrel. Correct. That is the highest frictional between the barrel and the granule. Here, the lower friction between the screw and the granule. Therefore, high degree of slippage between the granule and the screw. Low degree of slippage between the barrel and the granules. And therefore, it reduces the drag flow further. Again, there's a danger that the material staying long time near the screw root will degrade and contaminating the product. Yes. We have to hit the screw. Otherwise, what will happen? The material start to degrade at the root of the screw. And that will contaminate the product. It is important to remember that the conveying ability of the screw is controlled by the frictional coefficient ratio. And therefore, shown by delta, it is important to maximize this ratio, frictional coefficient ratio. Under normal circumstances, the minimum value of a ratio that guarantees conveying is, therefore, it is a 1.4. Now, friend, here we are using the cooling of the screw, which will help the correct product, the optimum quality of the product. See now how the screw is, cooling provided here. See, there's a pipe. First, they're drilling a hole in the screw. See, this is a hole here. Complete bore. Right. Now, we are adding here a pipe. Right. A small diameter pipe as compared to this drill hole. Correct. Now, if you are adding a water here, what will happen? The water gets sprayed here, direct at the tip of the. Even it is a perforated one. This pipe is also a perforated. That means it have a holes around it. And the water get fall in the screw. See now, the bore which is created. And see, when the water is fall from the pipe at the inside of the bore, the water is again collected here, hot water. See now here, so hot water. Therefore, friend, this is a very unique process to cool the screw. Therefore, it is recommended to prevent the decomposition of the material, sensitive material. Therefore, it is also recommended to use the cooling fluid at the temperature above the softening point of the principal polymer components. Any question here, friends? Hello? Any question here? Screw cooling. I told you, if you want the correct output of the extruder, you have to cool the screw. And there are a number of benefits by cooling the screw. Hello? Am I audible to you, friend?
Sir, while doing operation,
Yes.
if with the help of water it is cooling the
Yes.
screw,
Huh.
so if there is any leakage, how we will know from for what reason there is a leakage?
See, I told you in the screw only, we are drilling the hole here. See now. Right. From the shank, hub, and completely feed zone, compression zone, metering zone. We are completely drill. There's no leakage. And see, we are just passing here a pipe, small pipe, diameter pipe. Inside this, up to here. Therefore, water, a chilled water we are adding here from this place. And it will going up to the here. And then slowly it will again, it will fall here and get, spread here inside. And see, here the outlet to, जैसे हमारा घर पे बाथरूम में होता है पाइपिंग, सेम थिंग, देयर इज नो लीकेज एट ऑल. हेलो.
Yes, sir. Yes, sir.
There is a, see, there is a system is there, right? Therefore, completely the water which is coming out that gather here and it will again fall here. It is the outlet to go hot water and there is the inlet to pass the chilled water inside.
Okay, sir.
Due to this, what
Only
happens?
hot water will only drip down.
Here, the water here, water is the spraying. You are just spraying here water, and it fall down here, because it's a
Okay.
pipe, a small pipe. And see the diameter, the drill थोड़ा ज़्यादा बड़ा है. It may be 6 mm drill, and see the pipe is only 2 or 3 mm diameter.
Okay.
Therefore, the spraying water inside, it get immediately cool, and the hot water, see, after it absorbs the heat from the screw, and the hot water comes out. This is the outlet, this is the inlet. And friend,
Okay.
this screw cooling increase the production. Screw cooling decrease the friction between the granule and the screw. In vice versa, I can say you that it will increase the slippage. Screw, if the screw is cool, then there may be a lot of slippage between the granule and the screw. The material will not get stuck to the screw because of it is a chilled one. But see, the barrel is heated one. Therefore, the material, there is a higher friction between the granule and the barrel as compared to the screw and the granules. This is a benefit to get a right production, a complete positive flow of the material. There are many advantages of screw cooling friend. Now, breaker plate and screen packs that I told you yesterday only. See, these are the functions of see, this is a breaker plate here. Somebody asked me, sir, what is the breaker plate? This is a breaker plate, friend. See now here, this is a breaker plate. See, here is a central hole are there, circular hole, and that hole may be, 3 to 4 mm diameter. How much? 3 to 4 mm diameter. And here only we are adding screen packs. Therefore, this is a assembly. This is a barrel. This is a die, barrel, and here is a screen pack and a breaker plate. दोनों है इधर. In between the barrel and the die. Here is our screw tip here. Therefore, material pass from this. Here is a screen packs, and here is what? See the slots. It is again conical. See now here, and here. This is a side view, side cross section of this breaker plate. This, and it is it is get attached here by the barrel and the die. Right. Now, see, which will join this breaker plate and screen plate will join barrel and the die. It convert the spiral flow. I told you in the streamline flow. See now here, flow ऐसा आता है इधर, and this due to this will material go like this. It will go straight like this, The flow will be laminar or a straight line, right? And here the flow is turbulent, spiral flow due to the screw. Screw घूम रहा है, and the material also the rotating clockwise direction. Are you getting me, friend? Hello. Therefore, spiral flow convert into the laminar flow. The function of breaker plate and screen packs. And I told you the major function, here is a lot of pressure developed. And that pressure we want, back pressure. Therefore, otherwise the material will not go going forward direction. Okay. This create the back pressure. Screen packs at the breaker plate. Here is the pressure. Lot of pressure will be developed here. And therefore, unpressurized particle, foreign particle, create the pressure, right? And the back pressure, which is essential. And the last one, spiral flow into the laminar flow. Therefore, it will give the four function. Foreign particle can be stopped. Unplasticized particle maybe, stop. Then spiral flow into the laminar flow, and main function is create the back pressure. It is required. Without that, the material will not come from backward to the forward. Therefore, it is a very important frame. And where is place? I told you, between die and the barrel, at the in front of the screw tip. Any question here, friend? Any question?
No, sir.
Now we will go how the plastic travel through the extruder. Right. 1 minute. I have some video that I'm showing you. See now here, the material falling here. See the motor here. I told you, motor produce a very output. This shaft है, ये मोटर का आउटपुट है इधर. कितना स्पीड देता है? 1000. We have to reduce that. अपने को कितना चाहिए स्पीड here? 120, 120. Therefore, see, this is a gearbox. We are putting here oil, right, to run this. Okay. Now see here, due to this, that rotation decrease here. See here, cooling channel provided. Cooling channels. Here also the cooling channel. Here. ये ठंडा. This should be cool one. This should be cool. Remember this thing. Where water, here and here. Therefore, before starting the extruder, start your first work is to start water here and here. And then then set the temperature on the panel. Then set the temperature. First you start these, then start heaters. Wait for half an hour. Let the temperature increase at the set point. Temperature will increase here immediately within 10 minutes. But again, let it come to your set temperature. It will take again a half an hour. So wait for 45 minutes. Then how it come? Because the blower, it is a blower. 1, 2, 3, 4, 5. Suppose I told you temperature is going very fast. Within 10 minutes, यहाँ पे 100 था, यहाँ पे 150 हो गया इमीडिएटली 10 मिनट के अंदर. यहाँ पे हमको 150 चाहिए, इधर 200 हो गया. It increases to 200. Here I want 180, but here now 250. Now within 10 minutes the temperature increase, but I don't want such a temperature, high temperature. Therefore, immediately what happen? The sensor will give signal to the blower. It's a blower. It will start immediately, and within 15 minutes the temperature will here 100, here 120, here 180. Okay, it will again the temperature will settle here, friend. Therefore, this blower will work here. It's very important. There is a screen pack breaker plate are there. The screw is there. See, no valve is there. And see, this is a pipe die. This is what a pipe die is there. Circular die. The material coming here and they spread around this hollow part. right? Therefore, this now you can see this video, and if you have any doubt, you can ask me. This is the breaker plate. This is the breaker plate. See here is a wire gauge here, wire gauge. You are facing the screw is here, screw. Okay. So see now the half portion of this. See the slot is here. Half portion is with the barrel, and this half portion with the die. Therefore, it joined the barrel and the die. The screen packs and the breaker plate. This is a breaker plate. See the disc is a breaker plate, and here slot is there inside, and here we are adding the screen packs 60, 90, and 120 mesh size, 3-pack. And then we are just keeping here, which is facing the screw here inside, and this side die is there. Now you are getting the material from this number of holes this side. You have seen this breaker plate. There may be a 3 to 4 mm, the diameter of this, die breaker plate. See now here, there are a number of, this is the breaker plate. This facing to the now die. Die is here now. That side screw is there. See now half portion is with the barrel, and this half portion with the die. Any question here, friend? Any question? Hello.
The whole part we call it as die, no, sir?
Yes. The whole. No, this is a screen pack and a breaker plate assembly. It is a required in every extruder. Right now, this is a see now here. This is a after some time, if you run the machine for 8 hours, what will happen? After running the machine, this hole maybe that there are number of unprocessed particles, foreign particles, maybe metal particles that gather here, but they are not passing the outside. Okay, they all are here only, gather here, right? And then after that, after 8 hours again, you have to open this system and remove this screen pack inside and replace by the new one. Very simple thing. But you have to stop the machine for this. You have to stop the machine. Therefore, nowadays, the screen pack is a continuous screen pack is available. Continuous. Here is a roll of screen packs is added here, and this continuously going like this. Continuously. When the machine is on, that time the speed may be 1 inch per hour, like that. Very, very slowly. The screen pack slowly coming here. Here, the oven is there. The screen pack is heated at this temperature. so that there's no any effect of this. Nowadays, the continuous screen pack is available, friend. And whatever the screen packs here, the all the foreign particle and it is get round here. Here is unwinding, here is a winding of the screen packs. Okay, it is continuously going through this. Then again, there is a hydraulic screen packs are there, block, screen pack and a breaker plate. When here is a pressure gauge, we have to adjust here pressure gauge. Suppose we want 100 pressure gauge here, 100. When this pressure reach here 100, that time here is a hydraulic block, the same type of assembly is there. Immediately it will come here and immediately first it will go here. Immediately within a fraction of second, it removed and it will go here by hydraulically, and it will get replaced by the new one from this side immediately within a fraction of second, friend. This thing also happen in the industry. Hydraulic screen pack and breaker plate assembly and continuous screen pack and this also people are using nowadays. This is our manual, right? We are keeping the screen packs there, then we are stopping the machine like that. But in hydraulic and continuous type of screen changers, we not need to stop the machine. Remember this thing. Any question here, friend?
Sir, here which one is die and which one is the this thing?
See.
Breaker plate you told, that is breaker plate is the backside mesh only, no?
No.
Backside there was a white color mesh.
No. Breaker plate, it is in between the screw and the die. अभी die इधर die नहीं दिखा है, ये देखो this portion, इसके ऊपर हम die अभी अटैच करेंगे. Die हाँ, इधर die नहीं है.
हाँ, अब के बाद आएगा डाई.
हाँ, बस यहाँ पे डाई अटैच हो जाएगा, राइट. और डाई में भी स्लॉट रहेगा. इसका आधा पार्ट है ना, आधा पार्ट विल गो विद द डाई. Okay. Yeah. Now see the screen pack.
सर स्क्रीन पैक और वो ब्रेकर प्लेट में क्या डिफरेंस है सर?
हाँ, स्क्रीन पैक में क्या होता है, जाली होता है, जाली होता है ना. हम लोग देखो मच्छर.
ब्रेकर प्लेट,
हाँ, ब्रेकर प्लेट डिस्क होता है, डिस्क. ब्रेकर प्लेट आई विल शो यू. देखो दिस इज ब्रेकर प्लेट. यहाँ पे देखो ये ब्रेकर प्लेट है. अभी दिखाई ना डिस्क, अभी
राउंड शेप में जो है वो ब्रेकर प्लेट है.
यस. अभी वीडियो आपने देखा, राइट? यस, आई विल शो यू.
That back side, that white color is screen pack. Front side metal block is the breaker plate.
Yes. See now, he's removing now. He's removing the breaker plate now. See, this is a breaker plate.
Okay. Is there any standard, sir, for the holes?
See now, this is a breaker plate. See,
this is breaker plate.
Disc is there. और इसका अंदर से यहाँ पे इसको हॉलो यानी थोड़ा सा खाचा है. तो वहां पे हम लोग क्या डालते हैं, स्क्रीन पैक डालते हैं. 1, 2, 3 वेरी स्मॉल साइज, 60, 90 एंड 120 मेश साइज. ओके.
हाँ, उसके बीच में कुछ गैप होना चाहिए सर. तीनों मेश के बीच में.
हाँ, यहाँ पे गैप है ना, यहाँ पे
तीनों मेश के बीच में.
हाँ, यहाँ पे गैप है इधर. इसके अंदर स्लॉट है, स्लॉट दिया हुआ है इधर से. ओके.
60, 80 आपने बोला ना, 100.
हाँ.
तीनों मेश के बीच में कहीं कुछ स्पेसर लगा के करना है या कंटिन्यूसली आएगा वो?
नहीं, वो तो कंटिन्यूअस. यहाँ पे वो जाली काटना पड़ता है ऐसा, ये साइज का. ओके. और वो जाली काट के यहाँ पे हम डालते हैं एक 60 मेश.
एक के बाद एक कंटिन्यूसली आएगा. नो.
यस.
दोनों तीनों के बीच में कुछ स्पेसर नहीं आता है?
नहीं, कुछ भी नहीं है.
ओके.
यस. 3 सेट हम यहाँ पे डालते हैं, बस हो गया काम हमारा. ओके. या. See now, this is a breaker plate. See, यहाँ पे डाला, देखो जाली डाल दिया है. नंबर 60 मेश, 90 मेश और 120 मेश. 120 एकदम.
ये स्क्रीन पैक है.
हाँ, यस. ये स्क्रीन पैक से व्हाइट दिखता है ना, व्हाइट स्क्रीन पैक से. हाँ, और ये ब्लैक वाला है ये द ब्रेकर प्लेट.
Break it. This,
Yes.
what's the material of this one, sir? Screen packer. It is a
Screen
stainless
pack-
steel or?
हाँ, stainless steel only. Correct. You are
Okay.
right. It is stainless steel
Mhm.
only.
Okay, okay, sir.
Okay. Yeah.
So, sir, one question. As
Yes.
you told that this screen pack is basically used to arrest the contamination, right?
Yes. Yes. Yes.
And same kind of like melting operation we are using for the injection molding also.
कौन सा ब्रेकर प्लेट? No.
No, that melting of plastic resin. So why for extruder we want to use such kind of filters? Because raw material is generally generally cleaned before the process.
Yes, this is the right question now. See, in extruder, we are using the bulky product, right? Continuous production, continuous. एक बैग चला गया, second bag, third bag, right? And see, many times what happen in the industry, some virgin material के साथ कभी-कभी metal particle भी आते हैं. Many times, that particle again it will should be, it should be stopped somewhere. Therefore, यहाँ पे वो foreign particle, कोई dust रहेगा, कोई कचरा रहेगा, कचरा यहाँ अटक जाएगा अंदर के साइड. ओके. देन सेकंड थिंग, सम प्लास्टिक वो मेल्ट नहीं होता है, कभी कभी वो वैसा ही रहता है, राइट? दैट अनप्लास्टाइज्ड ग्रेन्यूल वो इसके अंदर फंस जाता है. यहाँ पे इधर यहाँ पे फंस जाएगा. आई विल जस्ट शो यू. सी, इधर फंस जाएगा. ओके, तो आगे नहीं आएगा. देन थर्ड थिंग, ये जो आगे रहेगा ना, ये ऐसा आगे रहने से आप लोग को प्रेशर मिलता है बैक साइड, क्योंकि वो अलाउ नहीं करता है ना मटेरियल को आगे, राइट? द मटेरियल विल नॉट कम फॉरवर्ड. इट क्रिएट द बैक प्रेशर. ये अंदर का जो स्क्रू है उसके प्रेशर रेडी करता है. एंड दैट प्रेशर वी वांट एक्चुअली फॉर द एक्सट्रूजन. बैक प्रेशर शुड बी देयर, नहीं तो फिर आपको मटेरियल आगे नहीं आएगा. इट इज वेरी इंपॉर्टेंट. देयरफॉर बैक प्रेशर, दिस उसका फंक्शन वही है, टू क्रिएट द बैक प्रेशर, so that the material will homogeneous get melted and it will come forward. फोर्थ रीजन क्या होता है इसका फ्रेंड? सी, स्क्रू ऐसा घूमता है एंटी क्लॉकवाइज, ऐसा. तो ये मटेरियल ऐसा स्पाइरल शेप में आता है, मेल्ट. इधर ऐसा स्पाइरल शेप में आएगा. दैट मटेरियल, फिर ये स्पाइरल शेप आप लोग को नहीं चाहिए. वी वांट मटेरियल शुड बी लिनियर, एकदम स्ट्रेट आना चाहिए मटेरियल. तो ये क्या करता है, ये जो ब्रेकर प्लेट होता है ना, ब्रेकर प्लेट, ये देखो यहाँ पे स्लॉट दिया हुआ है, स्लॉट. आई विल शो यू. हाँ, देखो यहाँ पे स्लॉट दिया हुआ है. तो यहाँ से एक ऐसा मटेरियल ऐसा एकदम सीधा आएगा, धागा जैसा धागा, बराबर है. वी वांट दैट धागा, वी वांट दैट स्ट्रेंथ लाइक दैट. मटेरियल शुड कम लाइक दैट. ड्यू टू दैट व्हाट विल हैपन, द चेन गेट इलॉन्गेटेड, राइट? उनको एक डायरेक्शन मिलता है, एक सीधा डायरेक्शन मिलता है डाई में जाने के लिए. एंड देयरफॉर सपोज ऐसा मटेरियल, स्पाइरल मटेरियल आएगा, तो दैट मटेरियल विल बी, you will not get a proper dimension and shrinkage. Many things will be there, right? Warpage. Therefore, to avoid that, we want a laminar flow. Laminar means सीधा flow होना चाहिए, not turbulent flow, right? ऐसा स्पाइरल फ्लो नहीं चाहिए. Therefore, this assembly will convert spiral flow into the laminar flow, straight वाला flow. समझ में आया क्या?
Yeah, right, sir. Got it.
गेटिंग ना? अच्छा, ओके.
Yes, sir.
तो फ्रेंड, दिस इज वेरी इंपॉर्टेंट. ये चाहिए. इंजेक्शन में कुछ जरूरत नहीं है. इंजेक्शन वी डोंट वांट ऑल दिस थिंग्स, because the granule, they are going from hopper loader and many things. There are again screening is there, and this type of back pressure not require. There is a valve is there, it will take care, and उनका सिस्टम ही अलग है. See, first thing, remember, the flow is non-positive, where in a injection screw, but here the positive pressure is there. See, this is a big difference. यहाँ पे इंजेक्शन मोल्डिंग में यू आर जस्ट फोर्सिंग द मटेरियल, फोर्सिंग, तो प्रेशर होता है बैक साइड, इंजेक्शन प्रेशर. यहाँ पे वैसा किधर है? नो प्रेशर यहाँ पे. एंड देयरफॉर to create the back pressure, we want this thing here, breaker plate and screen packs. Okay. And there also, in injection molding, a sprue is there, a runner, gate. तो जो मॉलिक्यूल आता है दैट गो इन स्ट्रेट, वो सिस्टम में चलते हैं लाइक मिलिट्री जैसा, बिकॉज मटेरियल हैज टू पास थ्रू रन स्प्रू, रनर, गेट, देयरफॉर वो सीधा आता है सब मटेरियल। वैसा इधर है ही नहीं, डाय में इतना है नहीं, डाय में नो स्प्रू, नो रनर, नो गेट, नथिंग इज देयर, एंड दैट्स व्हाई here we want breaker plate, friend. Are you getting, friend? Hello?
Yes, sir.
yes, sir.
Please go ahead.
Yes. See, the screen mesh are, if you see the size 40, 60, 80, see, many people, they are, using as per their material, as per their experience. There may be 60, 90, 120, like that. This is a mesh size, friend. जैसे हम बोलते हैं ना, चावल का सीव, व्हीट का सीव, बाजरा का सीव, लाइक दैट, इट इज लाइक दैट ओनली, फ्रेंड, राइट? ओके, बड़ा बड़ा ग्रैन्यूल रहेगा तो इधर गऊ, दिस सिस्टम में भी चावल, दिस में भी बाजरा, राइट? इट डिपेंड्स, द सेम थिंग हैपनिंग हियर आल्सो, द मेश साइज। व्हाट इज द मेश साइज? देखो, यहाँ पे ज्यादा होल बड़ा रहेगा, यहाँ पे थोड़ा होल कमती रहेगा, और यहाँ पे डायमीटर एकदम कमती, होल का गैप बहुत कमती रहेगा। ओके, देन अरेंज द
40, 60, 80 is per square inch. No, sir?
yes. What is
Okay.
there? See, number of holes per square inch, that is called as a mesh is a unit for that mesh. Number
Okay,
of holes, एक square inch में, one square inch में how many holes are there? That is called as a mesh size. मेश का मीनिंग क्या है कि एक स्क्वायर इंच में कितना आता है, वो 1 इंच ऐसा लेंथ, 1 इंच विड्थ, उसमें दोनों के अंदर कितना होल आएगा, दैट इज कॉल्ड एज मेश साइज। यहाँ पे 40 आता है, यहाँ पे 60 आता है, यहाँ पे 80 आती है, देयरफॉर हियर ज्यादा होल ज्यादा बड़ा है, यहाँ पे होल थोड़ा मीडियम है, और यहाँ पे एकदम छोटा होल है, छोटा होल। दैट्स व्हाई आई टोल्ड यू, दिस बाजरा, दिस राइस, this may be for the gau and a wheat, right? I have given an example to you of this. Now the screen pack, I told you, arrange the unmelted particles and contamination and help in developing the back pressure. Okay, these are the function of screen pack at the breaker plate assembly. Now you just go this video. I'm just
ये कौन सा प्रोसेस है सर?
Wait, I will tell you. Wait some. See, friend, this is a a unique video. How the the aluminum that we are getting the sheet of aluminum, rod of aluminum, right? Profile of aluminum. So how that get extruded? See here also, if you see here the aluminum's the block, it's called as a billet, right? See now here, see now it is extrusion only. See aluminum ka rod है चार 1 2 3 4 we are getting by putting the aluminum. See, I am showing you the metal. Metal का कैसा होता है extrusion. I am just telling you one example of how the metal get extruded. There is no any process. It's only extrusion, friend. Metal का metal, how you make the rod of a metal, of a aluminum, of a copper. The same process. See now here, this is a different process. There is no screw. See here, this is the only ballet you have to put there and you have to apply the pressure. Just I want to show you how the metal get extruded. It's a blade here, aluminum blade. Lubricant, yes. See now here, this is the aluminum actually. Aluminum block. Now is a force, ram. See, it's a die. And how this aluminum get extruded. See, this is a force here. See, completely the aluminum rod getting extruded. So, friend, just I have shown you this slide because see how the metal is extruded and how the plastic is extruded. There's a lot of difference are there. We cannot do like that. We cannot extrude like that. We have a extruder, right? Here is a ram extrusion. We have screw extrusion, right? Now, can you tell me how the Teflon and ultra high molecular hydrogen polyethylene, these two material can be extruded by this way, friend? This way, metal, daisa. Same thing. See now, same thing here. Cold extrusion. The die is here. See, this is a aluminum rod. How the animation? See now here. The rod is pushed to the press. You will get a cross section like this. See, this is a forward extrusion. This is the extrusion for the metal, you know.
Sir, in this, where the material is getting heat?
Yes, it is not heated. It is just cold. That's why, see, it is a cold extrusion. क्या बोलते हैं इसको?
Okay.
It is not hot
हाँ.
extrusion. Cold extrusion, friend. बस
So
मेटल
the
का ब्लॉक.
final product will be coming under pressure only.
यस 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 रैम्प
By
रैम्प
heating.
इतना जोर प्रेशर लगाते हैं रैम्प का, वो ऑटोमेटिक हीट हो जाता है. आपने देखा होगा एनिमेशन में, रेड वाला. तो that completely get heated inside only by the pressure only, friend, and it will get extruded. That is called as a cold extrusion. What? Cold extrusion. See the die now. Die is like this. You will get a profile like this. See the now metal rod, metal bar is now there. Dummy block. I say you will get such a shape now. See now. Look at the shape. This is extruded product. This is a backward and forward. There are two type of extrusion, backward and forward in a metal. See, this is the aluminum block, RAM, container. See now, it is a pushes like this. You can do backward and forward extrusion. Now, friend, you see this our extrusion line is there. No, we have seen this slide. No. We have already seen this. This is a panel, friend. This is a hopper. This thrust bearing here. Hopper is there. This a cooling is there. Now see from the bottom here. This is a barrel. There is a blower. 1, 2, 3, 4 to control the heat. See here. These are the blowers. See that this is a block. Direct hydraulic block assembly is there. Screen changer, right? Direct hydraulic. एक बार इधर see now the die is here. Here is the see breaker plate. See the breaker plate here. This is the breaker plate. Once it is a now get here signal, then it is a block. Then immediately it will replace here, and the new will go inside. See that the strains are coming down here for the pellets. See the fumes. This is a die. It's a die frame. See here. How the strains coming. This is a guider. This is a cooling trap. This is a cooling trap. See here. Very long. See, very long one. This is again guider here. See, it's a cutter here. Cutting होता है इसका आगे. अब सपोज ये प्रेशर हो गया तो ये इमीडिएटली दिस विल गो इनसाइड. डायरेक्ट हाइड्रोलिक स्क्रीन चेंजर बोलते हैं इसको. सी द ब्रेकर प्लेट रेडी है, रेडी रखा है. And it will not affect the production. Remember this thing also. See, the cutter is there. Granule you are getting here, gather down. See the cutter. See the granules. Any question here, friend? We will again see this video tomorrow also, and we will stop here. We will meet tomorrow at 6:30. Okay?
Sir,
Okay,
only
sir.
one doubt. That strips, initially it was white color, and when it was cut, it is having white and some orange color. So,
Yes.
it is burnt. Or is it which material, sir? Is this?
No, it is a due to, see, it is a color only, and they have added the master batch there, right? At the last moment, and the effect will be, that due to the cooling, right? After cooling, the molecule become a denser, right? When it become a denser, then definitely it will try to change its color, right? So all the color particle come together and they show their, that the whatever color they want, right? That means, see, the color particle initially, the volume is large, but when they're going in the water, they can shrink and they are coming closer to each other, right? And therefore, the shade and previous shade and the gradual shade goes on changing, friend.
Okay, sir. Okay.
Yeah.
And one more doubt.
Yeah.
There is one hopper I have seen in the video. Only then there is no additional in this machine. There is no additional glass filler or any mineral addition or this retarder or any other.
No.
All
There is
those
a
things are not available, I think so.
yeah.
Right
There
now,
is no any port actually on the extruder. Port nahi hai, port.
Simple type of extruder.
Yes. Correct. Simple type of correct.
Understood. Thank you.
Yes. Okay. We will meet tomorrow, friend, at
Thank you.
6:30. Yeah. Good evening and good night.
Good evening.
Yeah.
Yes, sir.
Good night, sir.
Okay, sir. Thank you, sir.
Good night.
Good night.